Hey guys, so I wanted to give a little demo about how to use the test level inside the newly released Unreal Engine plugin, which integrates the Nano cryptocurrency. So first of all, we want to clone this project into a folder of your choosing. Wait for it to download. It's only a few megabytes, so it shouldn't take too long. There we go. Just going to open it in Explorer and open the project. It's going to complain it's not built. We'll say yes. If there are any issues with this step, you may need to open it in Visual Studio and build it from there. I've seen that happen sometimes when you're using a newer version. In the future, it might complain. Okay, so the level opened. I'm just going to build the lights in just so it looks a bit better. Okay, there we are. So I'm going to click play. So the first thing we need to do is create a seed. I'm going to show how all these blueprints work in a sec. I'm just going to give a demonstration of the level. Okay, so it's created this account for us, stored the seed. We haven't got balance, so we can go to this next thing and scan a QR code to give us some funds. I'm just opening Atrium up on my phone. Send. There we go. In the top left, I don't know if you caught it, but that's where most of the messages will appear, like debug messages. And I just sent myself some raw, and to generate some PAL for it, and then receive the block. So if I go back to here now, you can see the funds have been pocketed. Generate some more PAL and send it to this spaceship. So anything that says requires generating PAL first means you have to go back to here to generate PAL. There's some utility functions which I'll get to in a sec though. So here we can pay to enter into an arcade style setup. I'm just going to scan the QR code again with my phone and send. There we go. Paid. And now this is if your arcade system was wanted to pay out some Nano. It also supports that QR code. So I'm going to scan that. And there we are. It's paid out. There's also an expiry on there in case someone never pays out. So this is a server-side block handoff. So it generates the block locally, hands it off to the server, which processes it, and then when it's confirmed, opens this wall. So here's another one that I need to generate PAL for first. So come back here, generate PAL. Come back, and if you look in the top left, it should say, yeah, sent. And that sends 5,000 raw to this account. Spaceship. This is a one that encapsulates the generating of the PAL and the processing of the block all into one. So just go straight there, and then you can see the hash in the top left. This only sends 100 raw. But these are the utility functions which are most useful when you're trying to integrate the plugin. This registers your current seed for automatic pocketing of funds. So if I come back here, I've got no pending and balance. So if I top up some funds, back onto my phone on Atrium, Nano. Okay, topped up, and you can see we didn't even get to see it go to pending. It was pocketed almost instantly. So that's pretty useful in a game situation if someone sends you Nano and you just want to pocket it as soon as possible. This is just watching another account. So I sent this account 100, and then the blueprint is just watching confirmations for it and then updating it. And this is listening for all WebSocket events, so all confirmations from the Nano network. So it can update quite quickly. And this just tests a bunch of blueprint functions. But one of the things it does do is the seed you just created, it stores on the file system. So it's just created this file, which is an encrypted seed based on a password, which is in this case is a default of my_password. So anytime you come back to the test level, you can read it using this, what you would call it, this poll. I'm just going to call it poll. So if I exit, come back in, so if I go to this, it's just going to create a new seed with 0 balance. Whereas if I come here, it's going to reload that previous seed I'd created. So it's going to read it from the file system, decrypt the ciphertext. Now I don't have any others saved, but if I come back here and then create a new one, then I can sort of cycle through them. Okay, that's sort of pretty much shows off the whole level. Actually, what I can do is just prove that the server-side validation works. So open 2 clients with a dedicated server. Come back here. This client also come back here. This guy is going to open. It should. Oh, that didn't work. Something. Oh, did I not do that? I did. Boom. So it's done it for both people, and that's done on the server side. Okay. So I'm going to explain how some of these work. Oops, what am I doing? So there is a game instance blueprint which stores 2 variables which are pretty essential. They're the Nano Manager class and the Websocket class. So you're going to need to construct a new Nano Manager and set it to whatever the RPC proxy server is. So this is a publicly available one at the moment, which we're just using for testing. So you'll also be able to use it as long as it's still running. And then you also want to create a WebSocket, which again points to the WebSocket server. And this step's pretty important, which it sets up the listener for the WebSocket internally and is what fires off a bunch of the events. So make sure to call that. and all the logic for all of these box thingies is in the polls themselves, and they're all named BP underscore. So this is named BP underscore new account, and this is not really consistently named, but they're generally corresponding. So this one's BP underscore QR code. This is QR code. So if we edit this poll blueprint over here, generally a few consistent ways they operate. So in the event begin, I get the game instance, which is where the Nano manager and Nano Websocket are located, and a few other things like the current seed and the account, just a helper thing for that. The work that was last generated, and this is for the server side stuff. So it knows what payment account, it knows what account to pay to, and also in the game instance, I set up this little watcher which is listening for events from the WebSocket for that account. Okay, so here, useful stuff starts here. So there's a function, a blueprint function called createSeed, and that's really what it does. I then store it in the game instance, get the account, and it's just setting the text on the box. And here I'm just polling the account balance using get wallet balance. It's like the easiest way to find out what the balance is of an account. And this sets up the watcher for that for that latest seed. I'll explain that a bit later. What else is there to show? QR code. So yeah, so I've tried to document all of the different blueprints. So this is a blueprint widget that comes with the plugin. And if you want to see the contents, what do you have to do? Okay, sorry, it's down here. Show plugin content. I get rid of it. Those disappear. But I enable it. Go to Nano content, and that's where the QR code widget is found. It's the only one I have. It's quite a nice helper thing. It's just a quad, so it's still useful. Then we call this function. There's a few variants of this. This one just takes an account, but there's also one that takes an account and an amount, and then one that takes a private key, which is used for the payouts. So maybe watching all the WebSocket stuff is useful. So this is not going to be actually like that practical for most people, because this is quite an intensive operation, especially if there's a lot of TPS on the network. You really want to filter the accounts you're watching, which I'll show in a sec. But, so you may want to disable this functionality. It's mainly useful for like visualizers, things like that. So what you want to do is you want to listen, call this listen all, and then bind to this event which just outputs every single WebSocket confirmation. And you can listen if you want. Let's look at watching. Yeah, okay. So here, yeah. So here, there's this function on the Nano Manager called send wait confirmation. So you pass it the private key, it's going to generate a block for the frontier, and then it's going to set up a listener for that. So this requires that we're listening to the account on the WebSocket, which is what this new account set up. So you have to call watch if you want to listen to WebSocket events for an account. Otherwise, what it will do, it will just there's a fallback which polls the if the block's been confirmed, but for a better user experience, you want to be listening as quickly as possible off the WebSocket. There's also an alternative send, which doesn't wait for the network to confirm a block. So it'll be faster in some instances, but obviously not as reliable. So as soon as the confirmation has come through, then it will fire this delegate off. And just for debug purposes, I'm checking if it's confirmed. And maybe I didn't explain what these are. So this is when you first, two of you. So when you make it flash green, that's going to be this little flip-flop A. And then when you leave, it's going to fire off the B event. So it's useful for cleaning up anything if you want to. So like with the QR code, I hide it when I leave. I can show you that quick. So yeah, when we leave, I don't watch the account anymore. Then I check if it's still in the viewport. Otherwise, I remove the QR code widget. Maybe the server stuff's useful actually, because this has logic in the player controller. So this is two ways to do the same thing, that whole thing or this helper functionality. And it's toggleable with this condition variable. So what we do is, I'm reading the private key from the seed, calling a helper function which makes the send block, which is what this whole code is doing manually, which I wouldn't recommend, but there are instances where you may want to do that for whatever reason. And after the block's created, we then call this open door function on the player controller, just because that's one of the things where replication works correctly. So if I go to the BP player controller, which is a custom controller, it then just calls this open door event, which is executed on the server. So what the server does, so it takes the block you pass to it, it gets the frontier of the account, just basically does some validation to make sure that block contents is correct, and then it sends the block and then waits for a confirmation for it. And then if it's successful, then it just moves the world really, really high up, the world location of the wall really high up. So this would also require a watcher. That's what this sets up. Watches on the payment account, which is what it's being paid to. Here. Okay. I won't bore you with the rest. There's also a ton of documentation on the GitHub about it. But what I will show is how to set up your own sort of node and servers, because you don't really want to be relying on the test servers. Go to the game instance. So I'm going to run a node locally and also set up the servers locally. So for here, I'm just going to use the local host. Use the same ports. Oh, and one other thing to note is that this will only ever be called once on success, because we saw some issues with some implementations which didn't expect this to be called multiple times. Because what happens is I try and reconnect to the WebSocket server if there's an issue. So because I thought that's quite a useful feature. Rather than the game just breaking, it will reconnect to keep all the functionality going. But this won't get called again, which I think is the correct thing to do. Anyway, okay, so I've set up the WebSocket as well. So what I'm going to do. There's plenty of documentation about how to run a node, so I'm not going to bore you with all of that. But because I'm a developer, I'm going to run it from Visual Studio. My node. I'm going to go to the GitHub repository that I downloaded. Oops. I'm going to go into this test server project folder. I need to update some. No, I don't. That's cool. Okay, I don't actually need to update any of this. Okay, yeah. That's fine actually. What I do need to do is npm install, and then I want to run this server script. And as long as you don't see any errors here, then it should be golden. And we can just go back to our test level, play, and there's no errors in the top left, which is pretty much a good sign. And yeah, using my own service now instead of the public ones. Cool. All right. Well, I'm probably going to make another video on how to integrate the Nano plugin into a custom game. Probably just use the third party, the third person sample game. It's quite easy to integrate things into that. Okay, I will catch you guys later.